In this series of examples, we're going to search for different arrangements of embedded parts that we can see in the larger 5-pointed star on the right side of the screen. On the left side of the screen, we have a smaller, similar version of the 5-pointed star that we can draw on top of so that we can search under similarity in the shape machine for the parts that we want to inquire about. So we can search in the shape machine by selecting the search shape on the left and the target design on the right, and the red highlight shows the matches that are found. When we select one that we want, we can pull it apart from the original drawing and see the shape we are searching for on the right and the remaining parts on the left. Now we're going to search for another pair of closed polylines, but not with overlapping parts. Instead, we're going to search for them in the spatial relationship that we've just drawn on top of the reference star, so that they have a gap in between them. And using the similarity mapping in the shape machine, we can search for this exact arrangement as embedded in the 5-pointed star. And when we select one, we can pull it apart from the original drawing and see the shape we were searching for on the right and two remaining triangles on the left. Now the star is drawn as a single closed polyline so that it registers as one object in Rhino's data structure. But we can search for any of the embedded parts that we can see. All our searches so far in these examples have been for shapes that can map to the vertices of the underlying star. But what about really arbitrary shapes of many parts that don't have a straightforward reference to the underlying geometry? Here we're cutting the star with a lasso, kind of arbitrarily, randomly drawn lasso. You may be familiar with this technique from the work of Terry Knight. So under similarity in the shape machine, we can select this random shape on the left and search for it in the larger star on the right. And we can find the exact arrangement of these parts that we're interested in. And when we select one of the matches and pull it away from the original drawing, we can see the random shape we were searching for on the right and the leftover parts from the original drawing on the left. And we can verify that we have an exact match by moving the shape we were searching for over to the leftover parts and scaling it up to see that it all fits back together into a 5-pointed star. Now the 5-pointed star is defined by a series of broken line segments, even though our eyes can clearly still see the 5-pointed star. And Shape Machine can recognize that star that we see as well. To demonstrate that, we're going to now search the fragments that make up the 5-pointed star for a closed isosceles triangle. So under the similarity mapping, Shape Machine can find all of the isosceles triangles that are embedded in the 5-pointed star. And when we select one and pull it apart from the star, we can see that Shape Machine has redrafted the parts of the isosceles triangle and the concave quadrilateral in their maximal line representation.